morning, everyone. Today we are going to start the new chapter, Vector Algebra. So in your 11th standard, in physics you had learned vectors, about vectors and scalars. In that, physical quantities are divided into two parts, scalars and vectors. So what are scalars? Scalars are physical quantities having magnitude only. Having quantities having magnitude only. Vectors are physical quantities having both magnitude and direction. Okay, so physical quantities which are of two types, scalars having magnitude only, physical quantities having magnitude only, and vectors are physical quantities having both magnitude and direction. So you can note down this. Let us consider some examples. Classify the following as scalars and vectors. So the first one is 5 seconds. What about this? Scalar or vector? It's a scalar. Okay. Another one. Can you hear me? Okay, so let us continue. So here 10 Newton what about this 10 Newton scalar or vector? Newton, it is the measure of force, unit of force. So force is a vector quantity. It is a vector quantity. Now 30 kilometer per hour. What about this 30 kilometer per hour? Unit of kilometer per hour, unit of speed. Unit of speed. Then if we consider this as speed, it is a scalar. Then one more 20 meter per second towards north. 20 meter per second towards north. This is a vector, its velocity, so it is a vector. See, in case of physical quantities, these are scalars and vectors. But here, in this chapter, we are going to learn about vector algebra, that is algebra of vectors. In algebra of vectors, we have to learn addition, subtraction and multiplication of vectors. Okay, so for that, in maths, when we consider a vector, it is a directed line segment. Vector is a directed line segment. Okay, so in maths we are dealing with this line segments and also the properties directed line segment, which is called a vector. So here a line segment AB is given, its direction is also given. So this directed line segment AB is a vector, which is denoted by vector AB, or we can write this as vector A So vector is a directed line segment, and here AB is a line segment and the direction is indicated by this arrow mark. We can denote this vector AB by this notation, or you can write this. since the direction of this vector is towards right, that is towards this direction, vector is starting from A and ending in B. Here A is called the initial point and B is called the terminal point. A is called the initial point and B is called the terminal point. The point A from where the vector AB starts is called the initial point and the point B where the vector AB ends is called the terminal point. Okay, see the directed line segment AB. That means directed line segment means the direction is also given here. AB is the line segment. We start from A. So the initial point is A and it ends in B. Therefore this B is called the terminal point. Also the distance between the initial point and the terminal point is called magnitude of the vector AB. Magnitude of vector AB and is denoted by modulus of vector AB or modulus of vector A, or you can write this simply as A. So if we consider the line segment AB and the direction is given here, so how can you represent this vector? We write this as vector BA and we read this as vector BA. Notation is BA and above this you have to mark the symbol for vector. So it is vector BA. Which is the initial point here? Initial point is B. Which is the terminal point or final point? Initial point, terminal point is A. The initial point of this vector is B and the final point of this vector or terminal point of the vector is A. Is it clear? Always remember we are considering points, so this A, B, etc. all these must be in capital letters. Okay, now write a question. Represent graphically a displacement of 40 kilometer (30° west of south). 30° west of south. Represent graphically a displacement of 40 kilometer which is 30° west of south. See, we have to draw the directions here. So this is for east, west, north and south. And we have to represent a displacement of 40 kilometer. The distance is 40 kilometer and it is 30° west of south. West of south. So first we have to move towards south. This is the south direction. From here we have to move 30° towards west. From here either we can move towards this west direction or towards east. Here we have to move towards west direction and that is 30° from here. So 30° and 40 kilometers. 1, 2, 3, 4. So let this divisions. 1 centimeter represent 10 kilometer. So this is 40 kilometer and the final position is here. Let this be equal to OP. OP represents 40 kilometers. (30° west of south). You have to mark these points. Write the scale. One centimeter is equal to 10 kilometers. So 10 kilometer here, 20, 30, 40. We reach this P. OP represents the required vector. Is it clear? Okay, now next heading, position vector. Next is position vector of a point. The vector OP having the origin O 0 0 0 as the initial point and P x y z as the terminal point is called the position vector of the point P. Is called the position vector of the point P. The vector OP having the origin O, which is coordinates of origin 0 0 0 as the initial point, and the point P x y z as the terminal point is called the position vector of the point P. And you know that the coordinate axis in three-dimensional geometry, that is x-axis, here y-axis and z-axis. A point P x y z in space, then the line segment joining this origin and P. The vector OP with initial point as the origin and terminal point as Pxyz. This is known as OP. OP is known as the position vector of the point P. And if we represent the position vector of P as vector R, which is vector OP, the position vector of this OP represented by vector R. What will be the magnitude of this vector R? What is the magnitude of vector R? Magnitude means length of this line segment, OP. You know that this coordinates of this point is 0, 0, 0 and coordinates of this point is x, y, z. How can you find the length of this line segment? Last year you had learnt distance formula. Coordinate geometry you are learning distance formula, and that is x2 minus x1 root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So it is root of x square plus y square plus z square. So this is the magnitude of the position vector OP. See, once again, consider a three-dimensional plane here. So in that a point P, X, Y, Z is given. To find the position vector of this P, it is the directed line segment OP whose initial point is the origin and the terminal point is the point P itself. The vector OP is the position vector and whose magnitude is given by root of x square plus y square plus z square. So let us now move to the next term, direction cosines. For that, let us consider the three coordinate axes, a point P, x, y, z, let us complete this. So here we complete this as a cuboid, and here let us consider this as pxyz. Now x axis, y axis and z axis. This is x, that is O. From O to this point the distance is x, O to this point the distance is y, and O to this point the distance is z. OP is the position vector. This line OP is the position vector of the point PXYZ. Let this line makes an angle alpha with the x-axis, beta with the y-axis and gamma with the z-axis. See, the directed line segment OP makes an angle alpha with this x-axis, beta with y-axis and gamma with this z-axis. So the angles alpha, beta and gamma are called direction angles. Okay, this you have to imagine one vertex of this cuboid is considered as the point PXYZ, and one vertex of this is the origin. So when you join these two, we are getting a directed line segment here, that is OP. We are considering the directed line segment OP, and it is the position vector of the point PXYZ. This line segment make angles with the x-axis, y-axis and z-axis, which is to be taken as alpha, beta and gamma, which are known as the direction angles. Now if we take the cos ratio of this, that is cos alpha cos beta and cos gamma. If we take the cos ratio of these angles, cos alpha, cos beta and cos gamma are called the direction cosines. These are called the direction cosines and are denoted by L, M and N respectively. These are denoted by L, M and N respectively. So the line segment OP makes an angle alpha with x-axis. Cos alpha is a direction cosine. If it makes an angle beta with the y-axis, then cos beta is another direction cosine. These are together known as the direction cosines of P. Direction cosines of OP, the position vector OP. Is it clear? These terms are very important and the notations also. We are denoting the directions cosines by the letter L, M and N. Now this L square plus M square plus N square. Let us find what is the value of this. L square plus M square plus N square. See, if we consider this x-axis and the point P, OP is the directed line segment OP, then we can form a right triangle here. This is the x-axis, this point is P and here it is x, y, z. The coordinates of the point P are x, y, z. OP makes an angle alpha with the x-axis and you know that this length is x and this OP is R. Magnitude of this OP is R. So what about cos alpha? Cos alpha is equal to adjacent side by hypotenuse. So here it is x by R and cos alpha is denoted by L. L is equal to x by R. Similarly, we can define cos beta. What will be the value of this cos beta? See, this is x and we are joining a perpendicular from the point P to this one, that is P to x-axis, and OP, the magnitude of the line segment OP is R and this length is x, this is alpha. So cos alpha is defined as x by R. Also the cos alpha is denoted by L, so L is equal to x by R. What about cos beta? Similarly, you can define cos beta. Instead of this x-axis, you have to consider y-axis here. Okay, it is cos beta is defined as y by r. And what about cos gamma? Instead of this y-axis, you have to consider z-axis and the directed line segment OP. So cos gamma is z by r. Z by r. That is m is equal to y by r and n is equal to z by r. This is m and cos beta is denoted by m. Cos gamma is denoted by n. N is equal to z by r. What about this L square plus m square plus n square? L square is x square by r square plus m square is y square by r square plus n square is z square by r square. So it is x square plus y square plus z square by r square. Okay, this r square is defined here. R is defined as root of x square plus y square plus z square. So r square is x square plus y square plus z square. Therefore L square plus m square plus n square is equal to 1. Is it clear? Always you have to remember this. L, M and N are the direction cosines. That is L is cos alpha, M is cos beta and N is cos gamma, where alpha, beta and gamma are the direction angles. And also if direction cosines are given, that is L, M and N are given, then L square plus M square plus N square is equal to 1. Always it is equal to 1. Now let us move to the next term, direction ratios. The numbers A, B and C, which are proportional to the direction cosines. Are called direction ratios. The numbers A, B and C, which are proportional to the direction cosines, are called the direction ratios. Now we know that x is equal to, sorry, L is equal to x by r, m is equal to y by r, and n is equal to z by r. Or we can say that x is equal to L r, y is equal to m r, and z is equal to n r. So the coordinates of the point P, x, y, z can be represented by P, L, R, M, R and N, R. See, we are considering a point P, X, Y, Z. From that we are making all these definitions, and this coordinates of the point with respect to x, y and z axis, that is x, y and z, can be represented by L, R, M, R and N, R. See this number L, R, it is proportional to the direction cosine L. We can write this as L, R by L, which is equal to R, M, R by M, which is equal to R, N, R by N is equal to R. So if we consider this L, R as A, this as B and this as C. See, L, R is taken as A, M, R is taken as B and N, R is taken as C, which are three different numbers. And these numbers A, B and C are proportional to L, M and N, because A by L is equal to B by M is equal to C by N. This is equal to R. This L, R is a number which is to be taken as A. So A by L is equal to R, B by N is equal to R, C by N is equal to R. See, direction ratios are some numbers which are proportional to the direction cosines. And from this you can write a relation between this direction ratios and direction cosines. See here, L is equal to A by R. So you can write this as L is equal to A by R, M is equal to B by R and N is equal to C by R, where R is root of x square plus y square plus z square. And you have to remember L square plus M square plus N square, that is, if we take the sum of squares of the direction cosines, then the answer is equal to 1, but A square plus B square plus C square may not be equal to 1 in all the cases. Okay, remember this property, L square plus M square plus N square These are the direction cosines, L, M, N are the direction cosines. This will always be equal to 1. And this a square plus b square plus c square need not be equal to 1 always or in general. Is it clear? Okay. Now let us move to the next one. Types of vectors. Types of vectors. First one is a zero vector. A vector whose initial point and the terminal point coincide is called a zero vector and is denoted by a vector whose initial and terminal points coincide. That is, initial point and terminal point are same. Then it is called a zero vector. What will be the magnitude of a zero vector? What is the magnitude of a zero vector? It is 0. That means the initial point is A and the terminal point is also A. That it means it is not moving from here. And we can consider the direction of the zero vector in any direction. That is, we can represent it as AA, vector AA, or it is BB, etc. This can be taken as a zero vector. Okay, now the next one is a unit vector. Unit vector. A vector with magnitude one unit is called a unit vector. is called a unit vector. See, a vector with magnitude 1 unit, that is the distance or the length of the line segment is 1 unit, then it is called a unit vector. And a unit vector in the direction of vector A is denoted by A cap. So a unit vector in the direction of vector A is denoted by A cap. This is the symbol used for unit vector. And third one is co-initial vectors. Co-initial vectors. Can you define this? 0 vector means the magnitude vector having magnitude 0, that is initial point and terminal point coincide. Unit vector means it is a vector with magnitude 1. Can you define this co-initial vectors? Vectors having same initial point. Having same initial point. Vectors having same initial point. Vectors having the same initial point are called co-initial vectors. Now the fourth one is collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same line. If they are parallel to the same line. Parallel to the same line irrespective of their magnitude and direction. Irrespective of their magnitude and direction. See, we can consider a line L here, a vector A which is parallel to this L. This B is another vector which is parallel to L. This is another vector parallel to L. In magnitude, A and B are not equal. Okay, B is greater than this A. Magnitudes are different here. Directions are also different. But these two vectors are parallel to the same line L. So we can say that A and B are collinear vectors. A and B are collinear vectors. Not to consider the magnitude or direction, but the vectors must be parallel to the same line. That is, they are parallel to each other. Then we can say that vector A and B are collinear vectors. Now the next one is equal vectors. Vectors having same magnitude and direction. Vectors having same magnitude and direction. Are called equal vectors. Vectors having the same magnitude and direction. The position of the initial vectors are not considered there. And the next one is negative of a vector. A vector whose magnitude is same as that of a given vector but the direction is opposite. Is called negative of the given vector. Is called negative of the given vector. For example, negative of vector AB is BA. Negative of vector AB is BA. Magnitude is same, length of the line segment AB in both these cases, but here the direction is from A to B, here the direction is from B to A. So this is negative of a vector. So with this, let us conclude today's class. So in this you have to learn what are vectors, and then what is position vector of a point, then direction angles, direction cosines, direction ratios, then different types of vectors. Okay, we will do the remaining in the next class. Thank you.